So in this lecture, we are going to study about the Turing machines and undecidability concepts. Okay. So this is an introduction lecture for the Turing machines and undecidability concept. Uh, First, before going to the Turing machines, we first see what is a recursive enumerable language. So recursive enumerable languages. So before explaining the definition of a recursive enumerable language, first I'll be saying with what are the topics that this recursive enumerable language deals with. So first, these languages deal with computability, algorithms, and the Turing machine. TM stands for Turing machine. So these languages are dealing with these three important concepts: computability, algorithms, and Turing machines. So what is a recursive enumerable language? REL for short. So the language which is generated by some REG and accepted by some Turing machine. So you see here REG means recursive enumerable grammar. So any language has to be generated by some grammar. In the case of REL, it is generated by REG, and any language has acceptors uh, by name the finite automata or pushdown automata or linear bounded automata. The acceptor for this REL is the Turing machine TM. So there are two types of languages. Recursive enumerable languages have another subset or another sub languages known as recursive languages. So REL is also known as computable enumerable problem. So as I said, recursive enumerable languages also contain some languages known as recursive languages. So recursive languages hereby I denote by REC. So for example, L be the language that generates natural numbers up to n. So you are given a number n, for suppose n is equals to 5. So it will generate the numbers 1, 2, 3, 4, and 5. So n is some value, some constant value that is given as input, and the generator grammar generates the numbers up to n. So you can see that this language is finite. So the we can say that we can say the range, we can easily say that the numbers that are generated are finite. So this type of language is known as REC. We'll say what is REC in short: recursive language. So let's see the language which generates natural numbers which are greater than n. For example, if you are given 5, you need to generate 6, 7, 8, and so on infinity. So this is not finite. This is infinite. So this type of languages are known as recursive enumerable languages. So this is the primary difference between recursive enumerable languages and recursive languages. So the above one which you see, this generation of natural numbers up to n is a recursive language, and this generation of natural numbers greater than n is recursive enumerable languages. Okay, so let's go with the formal definition of the recursive enumerable language and recursive language. So say there is a Turing machine T with input alphabet E that accepts language L is subset or equal to E star. So we are given some input E which contains some input symbols. E star denotes a complete universe with which the input symbols can the number of strings or the number of strings that are formed using these input alphabets can be formed under the E star. So every language is a subset of E star. So let's suppose there is a language L that is subset of E star. So the language is L. The language L is recursively enumerable if there is a Turing machine that accepts L. If there is some Turing machine that accepts L, and that is that accepts L, and that language is known as recursive enumerable language. And if L is decidable, then that language is known as recursive language. That Turing machine decides L, then you said that the language L is recursively enumerable if there is a Turing machine that accepts L. If this Turing machine also decides L, I just say what is deciding in short. For now, if a Turing machine accepts L, then that is a recursive enumerable. If that's the same Turing machine decides L, then the language is also a recursive language. So we now come to Turing machine. So Turing machine is an acceptor of recursive enumerable languages, and this is a base for solving and not solving. And that means that there are some problems which can be solvable, which cannot be solvable. So the Turing machine decides which can be solvable and which cannot be solvable. So the Turing machine acts as a language acceptor, language generator, and the mathematical computer or transducer. So these are the three roles that are played by the Turing machine. So the computability is mainly of two types: the total computability and partial computability. So in order to see what is total computability, let's first go through an example. So if there is a function n which maps from n to r, where n is a natural numbers and r is a real numbers, so f of x be the square root of n. So for every natural number as input, we get some real number as output. So f of n has the real values for every input that are taken from the natural number set. So then for every input we get an output for every input, since the input belongs to the set of natural numbers. So the output of this is a real, as belongs to as it maps from n to r, the output belongs to r. So this is said to be a total computable function. So let's see another example. F maps into r, f of x. Sorry, this has to be r to r. So if it is r to r, r contains the negative numbers as well. When the square root of something is the square root of a negative number is not a real value. So the square root of something is not a real value, then the mapping into r to r, the outcome of this doesn't fall into the real set. So some of these input don't have the proper value in the output set. So these are not these are said to be the partial computable functions. So this is okay. We just discussed about the Turing machine and undecidability concepts, recursive enumerable languages (REL), also examples and formal definition of it, and also the Turing machine, which is based for solvability and unsolvability. And we also seen that languages acceptor, language generator, and mathematical computer. And we also seen partial and total computable functions. So thank you. See you for the next session.